Alright, let's go through this last one. It's a little bit tricky, but it's definitely something you could see, because if you take a look, I took this right from an old SOL test. Alright, so the diagonal lines bisect each other in the center of the rectangle. So right here, those diagonals are bisecting. Well, we remember that means to cut in half. Alright, so we want to find the closest measure of x, this little triangle, or this little angle right here. So if I redraw, if I'm going to look at just this triangle, I can redraw it over here. We want to find x. Well, is this a right triangle? No, it's not. So we can't use inverse trig right away. But if we look up again up here, it said the diagonals bisect each other, so they cut in half. Well, these two sides are parts of those diagonals. So if they cut in half, we know that the two parts are equal. So we end up with a triangle that has two equal sides. We call that, what kind of triangle? Hopefully you said an isosceles triangle. So if it's got two equal sides, it also has two equal angles down here. So now, let's see if we can figure out any of these parts, and that might help us find what x is. So if we take this back over to this problem, or this whole picture, I do see that since it's a rectangle, I've got this 90 right here. So I'm going to have 90 in all of my corners of this rectangle. So if I look at this bigger triangle here, one that I'm outlining in pink, if we draw that again over here, we see that this bottom corner is 90, this bottom side is 2, and this tall side is 8. Well, this is a right triangle, and I have two sides, so I can use inverse trig to find one of these angles. But again, let's look over here and figure out which of these two angles is going to be more helpful to find. Well, this little angle up here, I don't know if it tells us a whole lot about our blue triangle, so it might not be so helpful. But this angle down here is actually the exact same angle that I need to find over here. So I'm going to go ahead and stick a y right here, and we're going to solve for this angle. So I draw my focus angle franc, I label O, A, and H, and I see that I'm going to be using O and A. So with O and A, that means I need to use tangent. So tangent of y equals O over A. So if I type this in my calculator, I go second tan O over A. I get 75.96. So if we round that to the tenths place, this 6 is going to make the 9 go up. So we're going to say y equals 76 degrees. Alright, so if this angle is 76 degrees, then I know over here, I can draw a nice arrow over there, I know that that is 76 degrees. Well, if this is an isosceles triangle and these two base angles are the same, then this guy is also 76 degrees. Now if I want to find x, I've got two angles out of my three angles. So now I just need to use the fact that the three angles in a triangle equal how much? Okay, hopefully you said 180 degrees. So if they all equal 180, I can take away the two 76 degree angles that I do know. So 180 minus 76 gives me just 28 degrees left over. So x has to be 28 degrees. So now when I look back over my answer choices, this is awesome. I see it right here as answer choice C. So I know this question wasn't immediately inverse trig. It was a little bit of a challenge. but this is something you definitely could see. So all of this stuff we've learned about triangles is going to come together. You need to make sure that you are thinking about the whole picture. Good job, guys.